Okay guys, welcome to session number 2. Hopefully the first session on rearranging equations went well. We're going to go get straight into session 2, which is on surds. Really important topic at A-level. Again, this you would have covered this at GCSE, but it's just knowledge that's assumed that you know how to use surds and manipulate them really well. Right, okay, here we go. So we're going to go straight into a few examples on surds. First of all, you need to know how to simplify. So we're going to go straight in with an example of that. Let's say you want to simplify root 147 minus 2 root 12. Okay, so that could be the question. Now you'd be breaking these up into smaller. So basically the rule you're using is root AB is equal to root A multiplied by root B. That's a given rule in maths. So you're trying to look for a biggest square number that goes into both of these surds. So I'm going to always start with the easiest one. Biggest square number that goes into 12 is 4. So I'm going to split that up into root 4, root 3. 4 times 3 is 12. Okay. I'm then going to split the 147 up. I'm going to use a little bit of exam technique. I know that root 3 is probably going to be one of them, and I do know that is actually 49. So 49 times 3 is equal to 147. Right, I then just need to root each one that can be square rooted. So 49 can be square rooted to 7, root 3. This one I'm going to root 4 becomes 2. And then I'm going to just keep going. So 7 root 3 minus, that's going to be the same as 4 root 3. So my final answer, 7 root 3 minus 4 root 3, is just 3 root 3. Okay. Now you can check this on the calculator. Just while I'm on the subject of calculators, you must get the Casio Class Whiz calculator. This one here, you need this for A-level. Okay. So I'm just going to check my answer. Root 147 minus 2 root 12 and 3 root 3. So I know I'm correct there, which is good. Okay, that's example number 1. Example number 2, we're going to expand and simplify. So expand and simplify the following. Root 7 plus root 2. Times root 7 minus 2 root 2. Okay, again, a useful skill to use at A-level. So I just do it exactly as I normally would. So root 7 times root 7, that is just 7. Root 7 times minus 2 root 2 is minus 2 root 7 root 2. I can't really do much with the 7 and 2. I could make it root 14, but I'm just going to leave it separate for the time being. Root 2 times root 7 is just a singular root 2 root 7. And then root 2 times minus 2 root 2 is going to be minus 2 times root 2 times 2. Okay, because it's root 2 times root 2 is 2, and then times 2 is another 2. Let's just tidy this up a little bit. I've got 7 minus 4, 3. And then I've got minus 2 root 2, 2 root 7 root 2s, plus another root 2 root 7. So I've got minus 1 of these. Okay, and that is fully acceptable. You could also rewrite it as 3 minus root 14, because 7 times 2 is 14. And let's just check our answer. So again, with the Class Whiz, root 7 plus root 2 multiplied by root 7 minus 2 root 2 and 3 minus root 14. So they give it like that. So either is fully acceptable in an exam. Okay, 2 more examples to go. Example 3, rationalizing. So I want you to rationalize the following. 2 over root 3. Now rationalizing means to get the surd off the bottom of the fraction. Okay, the reason for that is computing can divide times by a surd slightly quicker than it can divide. So it's sometimes easier for computing in order to get the surd off the bottom there. So in order to do that, to keep the fraction the same, I need to times by 1. and I need to times by root 3 over root 3 because that's the same as timesing it by 1. I'm not changing it, but that will eliminate the surd on the bottom. So again, on the top I've got 2 root 3, and on the bottom I've got 3. And again, I can check this on my calculator. 2 root 3 over 3. Sorry, I put in the actual original, which is 2 over root 3. And yeah, 2 root 3 over 3. So now I'm correct. Okay, final one, because it's part A of rationalising. Part B, slightly harder rationalising case. 3 over 2 plus root 5. Well, again, we're trying to get rid of that root 5. You might want to have a think about what you need to multiply by. But the only thing you can multiply by to get rid of it is 2 minus root 5 over 2 minus root 5. Okay, again, that's still 1. I'm allowed to do that. We'll do a general thing on that in a minute. But if I do that, I'm going to get 2 minus root 5 over 2 plus root 5. 2 minus root 5. Let's keep going and multiply that out. The top is going to be 6 minus 3 root 5. The bottom is going to be 4 minus 2 root 5. You can probably see why this is going to cancel out now. 2 root 5 minus 5. Tidied it up a little bit. These two cancel, which is really nice. 6 minus 3 root 5 over negative 1. And again, when you divide by negative 1, it flips the sort of signs on the top, which is quite nice. So that's just going to be 3 root 5 minus 6. Okay, let's just check our answer. We can do that by typing in the original 3 over 2 plus root 5. And I get minus 6. Yeah, I've just done it in a slightly different order, but that's exactly the same. Okay, so in general, to rationalise a surd in the form x over, I don't know, let's put a plus root b, you must multiply top and bottom by a minus root b. Okay, it would work the other way around, or if you had x over root b plus a, imagine if it's in that way around, you would multiply, well actually if that was a negative there, so if it was root, you would multiply by root b plus a, so you change the sign of the second term. Okay, you change the sign of the second term. Right, that's the examples for surds. Obviously pause the video, go back if you need to just do a bit of a refresh. Again, it's the worksheet questions I want you to do after this. So the worksheet questions, I want you to do every question. So all of these questions you need to do, every question, including the extension, or the extend, and upload to the correct OneNote page. Okay, that's it for today's session, guys. Well done, and tune in for session 3 when you're ready. Okay, so tune in to session 3 when you're ready.